Czeczko. I am a front-end lead developer and a practice lead at Xerris. And I'm going to walk you guys through some of the work that we've been doing with one of our clients around bringing up data from literally a thousand meters underground. But first, just a little bit about me. Already mentioned I'm a front-end lead developer and modern web applications practice lead at Xerris. What that basically means is I'm supporting a lot of our clients in terms of different projects that we've been going on, and also building up best practices and architectures that we're serving to our clients. I'm also an AWS certified DevOps professional, and I'm really focusing on building out progressive web apps and micro front ends for a lot of our clients. A little bit about Xerris. Xerris is actually a remote first full stack solutions provider. We're based out of Calgary, Alberta, of course. It's a wonderful place to live. I'm a born and raised native here, so I will happily speak about how much I love living here every day. We're also an AWS Advanced Partner, Google Cloud Platform experts, and we are getting into the Azure space as well. And that little screenshot there is from one of our all hands from a few months ago. One thing that's really interesting is Xerris is scaling like crazy. I joined the company just over a year ago. I think it was number 13, and we're at just over 80 people right now. And so we're clearly doing things a little bit differently, building out solutions for our client. We're doing everything in the space from supporting a lot of our clients in their cloud migrations, DevOps work. A lot of our clients are also requiring custom applications built, whether that's web applications, full stack solutions. We're kind of in everything. We're working in a lot of different industries already, including retail, mining, agriculture. We're getting into a little bit of pharmaceuticals work, fintech, and a few other things there for sure. At Xerris, we like to say we solve for today and build for tomorrow. And so we've got a very diverse team. Not all of our team is based in Calgary, so we have people across Canada, some in the States now, some in South America as well. And so our team is kind of starting to spread out all over the world for sure. But we're really excited to bring on new people and grow our team. A day in the life kind of at Xerris, most people, typically it depends what the clients are working on, but I think it's probably a typical day for most devs doing, your typical scrum in the mornings, any client calls that you may need to do, and then also working just on delivery. We are an agile shop, so we really push our clients to make sure that they're running their projects through usually 2-week sprints. We've got scrum masters to support that, and product owners and all that sort of stuff as well. So really, overall, I've been with Xerris for just over a year now, and I absolutely love it. It's a really great place to work. And yes, we are hiring for quite a few positions, I believe, right now. So feel free to check out the expo page, as Sam has said, or directly on our website. So kind of what challenges are you working on now? We can get into a bit of the meat of the talk. And so what I'm really going to be talking about is one of our clients came to us with the issue where, and this is where the title comes from, 1,000 meters underground. We're working with one of our clients in the mining industry. And so their mines are, they're mining product out of these mines underground. Some of these mines are as deep as 1,000 meters, and they can be as wide as a small city. So, end to end, if you were to take a little Jeep or a buggy through there, you could drive over 25 kilometers underground from end to end. So these are enormous spaces. And what they're really trying to do is to modernize their reporting of hazards, production information, and all that, because their current process at multiple mines that they own is paper and telephone. So it'll be paper logbooks where people are recording the information and then bringing them up at the end of a shift, whether that's 8 or 12 hours, or potentially if the logbook gets left down there, it might not come up till later. And anything that needs to be dealt with immediately requires phone calls to the surface to mine engineers that are kind of operating and handling the whole situation. So they're really trying to modernize their operations. And they've started to deploy more technology in these mines. So that includes Wi-Fi in some scenarios, LTE in others. But the challenge that we have on this project is they're really looking to build out what's called a PWA. If you haven't worked with them before, it's like a typical web application you might build, but they're called progressive web applications, and they've been around for a few years, and they're trying to leverage more browser technologies that can include things like notifications, offline caching of images, so that your application can work even when you have spotty or no internet connectivity. And so that was one of the first requirements, is the client wanted to build a PWA and not a native application. because they've built a lot of web applications before. They're more comfortable with that, and they didn't want to have to get a dedicated team to now manage native applications. The other big thing was, of course, we've talked about it, it needs to support offline in all scenarios. So, if that's no network connectivity, that's one option. In some cases, while they're doing the work, there is network connectivity where they're doing the work, but then the reporting happens elsewhere. We need to be able to store this data offline for some period of time, potentially 8 hours, or if a device is left down there for longer periods, it could be 24, 48, 72 hours, potentially even longer. We need to handle spotty internet connectivity down there because it's huge. And you can probably imagine, just getting your Wi-Fi working in your house is a problem, let alone through tunnels that are just basically bored into rock. It can be pretty crazy down there to actually have a stable connection. And really prevent the losing of data, because some of the data that we're surfacing here is related to hazards and equipment, repairs that may need to happen. And so this information is critical to the operation and really cannot be lost. So we came up with our plan A, and some things didn't go so well. So a little bit of an architecture diagram here. We were looking for different solutions that we could actually build out. And so we basically had 2 applications to build here. We had our Mine app that's actually on the devices underground. And on the other side, we have our administrative application to manage all of this kind of information. Another requirement that we had is the client is using SQL-based servers. So the data has to end up there at the end of the day for other reporting applications to read it. So we're kind of constrained on that. And so we have done a lot of work with AWS on this project. And our initial kind of first crack at it, we decided to use a product called AWS AppSync and Amplify Data Store. So I'm actually really glad we had a talk about GraphQL a little bit earlier, because it's perfect. Because what Data Store and AppSync are basically doing is AppSync is a GraphQL service. So this essentially becomes our server to read and write data in GraphQL. That data ends up inside of Amazon DynamoDB. And Data Store actually exists on the client's device, on the iPads that they're using down there, and is this offline store. And we chose it initially because we were very comfortable with AWS products. And Data Store does a lot of nice work in terms of handling merge conflicts for you, supporting data to be stored offline. But then we actually ended up with the problem that because everything had to go back to a SQL server, we had to write kind of a complicated backend layer using a lot of different serverless technologies to kind of keep the data in sync between 2 databases effectively. And so we typically use REST on a lot of our projects. And so we had Graph over here, we had REST over here. And it quickly became an issue of the complexity of the project. We were writing a lot of code just to support this synchronization layer. And we realized that we'd likely, just due to some of the limitations that currently exist in the Data Store product, we likely wouldn't want to go to a production solution with this application. So we did kind of main problems really were that Amplify doesn't support schema changes once you kind of go live without some data loss happening, which in our case, in some cases, that's totally fine. The data is the same on the server and the client. And if we just erase the data on the client, then that's okay. But in our case, because we had no ability to lose that data, we could not allow that to happen. That was one of our big issues we weren't really able to work around. And this is something we brought up to the Amplify team and is hopefully going to get into their roadmap around supporting this. The other part of it is Xerris, we do a lot of DevOps work. And so really big on using infrastructure as code across all of our projects to make sure it's easy to scale, deploy our cloud architecture for our clients. It's just a lot easier to manage. Amplify is currently limited to a CLI. So there were some stability issues that we actually found when deploying our backend, and we ended up having to recreate it a few times. And then the third thing that I've already alluded to is that Amplify requires you to use DynamoDB currently because it's kind of a newer product. And we needed that data to go back to a SQL server. And so, we were ending up writing a lot of extra code for this. So we realized that let's start getting to plan B. And, when we finally cracked what we thought this could be, I remember one of our team members saying, now we're cooking with gas, and found that really funny. So I thought I would add that to the slide here. But you'll notice this diagram compared to the one you just saw is significantly simpler. And reason being is that we realized what was really our limiting factor was that we were using Data Store on the front end. And so we went to look at other solutions of offline databases that could support our clients' needs in the React progressive web app that we were building. We discovered there's an open source project and product called RxDB, which is a really nice offline database that supports syncing with either, CouchDB on the back end or GraphQL. And so we realized if we had adopted RxDB inside of the Mine application itself, what we could do is we could go fully to GraphQL on the entire project, retain AppSync because it's actually been a very nice way to run our GraphQL through a managed service, connect to our serverless backend, Lambdas that we're writing, and we could go down to a single data source. So all of the data could be, read and write in and out through exactly the same process. And then our administration app, because we were using REST on that side of things, this is actually perfect. We just talked about Apollo Client. We were able to adopt Apollo Client in our React front end to actually talk to AppSync and perform our queries for us. And so we've just kind of done this massive transition to do this work on this application and are kind of rolling along forward. And so what did this really give us? The problems that we solved, we have gained, a good client-side database that works for us. It's a NoSQL reactive database. So in terms of React performance and rendering, we can, listen to changes in the data that are happening, make sure we have a very nice responsive UI for our workers that are actually going to be using this application in these mines. RxDB is actually kind of great because it supports different schemas and versioning that schema. So if we make changes as we roll this application forward and expand it, we can just tell it how to handle those kind of changes when it gets deployed, and we wouldn't have any data loss at that point. It also supports syncing with actually 2 different protocols. So if for some reason we didn't want to use GraphQL, there's an alternative product that we can run on an actual server called CouchDB, which is a document database that it can sync with. So that was really great on that side. We could get rid of Amplify in this case. For now, we've decided that data storage isn't the product for this use case at the time, just due to some of the stability issues we had with it and the lack of support for the schema changes. So we've made that switch. We've also been able to adopt infrastructure as code back to all the different parts of the product now. So all of our deployments are then properly handled through Circle CI, through AWS's Cloud Development Kit for this project, to actually get all of the infrastructure spun up and spun down as we need across different environments for testing as well. And I'm sure you've noticed between the 2 different diagrams, there were a lot less things just on the screen to even worry about, which means we've actually been able to write, when we've done this rewrite, we've realized that we've taken out probably maybe at least over 1,000 lines of code on the backend side of things, just for that synchronization layer that we had to kind of have to go to a bunch of different places. And we're down to one solid data store. So we don't actually have to worry about, even just from a cost perspective for the client of running DynamoDB, their SQL databases as well. It kind of simplifies things a lot more in terms of the long-term viability of this project. The last thing was, how do we do this switch, kind of seamlessly pull the tablecloth out and not break everything that we already had in the existing place? And so we came up with this transition architecture, basically where we realized that, we're really comfortable with working with DynamoDB for now, but we realized to do the switch on our front ends, it's going to take our front end development team about 2 weeks to do this work. And we had estimated actually that the backend work, because we were unfamiliar with it, might take us up to 6 weeks. And the client is actually on quite a tight timeline on this project. And so they needed to make sure that they would give us 2 weeks to do the front end work, but we needed to continue on with new feature development as quickly as possible. And so our solution to this was one really interesting thing that AppSync has as a GraphQL layer, because really what's nice about Graph compared to REST at the end of the day is you can really have anything behind it. You could have it talking to an Elasticsearch cluster, a third-party API, a database behind the scenes, whatever you want it to be. AppSync actually supports directly creating what are called mapping templates that are written in a language called VTL, where you can tell it from these schemas that we have, here's how it maps to our tables directly in DynamoDB for the queries and the mutations, so the reading and the actual writing of our data. And so our front-end team was able to write this themselves and basically build themselves a mock working what we're calling the dev real app sync for now, and continue on with new front-end feature development while the backend team wrote the actual dedicated code that we needed to talk to RDS. And because we're using the same schema across both of these inside of our infrastructure, when this work is complete, when we're ready to go, all we have to do is switch the connections from this temporary app sync to these lambdas, and the schema will just continue to work. We'll be able to really pull out the tablecloth in one day, and the applications can continue to work because we're all operating on the same contract of data and how that schema looks inside a graph. So did we really meet the requirements? I didn't really talk about the actual building of the PWA, but yes, it is a React PWA that we're building out. We're also using Google Workbox to cache some of the files and assets there as well. We have been able to support offline in all scenarios. We found that RxDB is very resilient in terms of retries when connectivity is spotty or offline. So the data is always on the tablet itself, and if we come back online, it'll send up. Same thing with the spotty connectivity. If a time, like let's say a request, I'm sure we've all been there, just due to some reason has timed out due to a slow request or network connection, especially on our devices, or even just if a tablet is holding on to a bad Wi-Fi signal for way too long. I'm sure we've all had that happen before. RxDB can just keep that data and retry when it has a more stable connection, and really preventing the loss of data. So we know that data is always going to be on that tablet. It will never be cleared from the application itself. So as long as we can recover the physical tablet itself and it operates and can connect to the internet, which you might imagine in a mine, there's the potential for the tablet itself actually getting destroyed. But we can't really mitigate that one with software, unfortunately. So as long as we can grab that tablet, get it connected back to the internet, that data will sync up from the application back up. And yeah, that's all I really had to chat about today.